virtual meetup group. My name is Julie Blomquist. I'm here as a moderator today, along with a co-organizer, Paresh Modawala, and I think Teo Bali is also on. This is the information on our meetup and our email address and our Blue Sky. Feel free to communicate with the team and let us know how we're doing or what you would like presented. If you have a suggestion, feedback, need access to the shares, just send an email to the DBA-VUG@outlook.com. This session is being recorded and will be up on our YouTube channel. Our meetings are the second Wednesday, noon Eastern, and the fourth Wednesday of the month Pacific time. This gives everybody an opportunity to attend during the lunchtime. Again, this is where the recording will be available. We've got some great lectures out there that you can take a look at. These are the future sessions for 2025. There's also going to be a 6-part fabric series. This will be a wonderful opportunity to get caught up on fabric. There's also some future events. These are SQL Saturday and Data Saturdays that are coming up. These are one-day mini conferences in general, but it also is showing the Microsoft Fabric Community Conference and also the past Data Community Summit, which is in November. So these are the other SQL Saturdays and Data Saturdays coming up. Usually there's a they're free, or they just charge you like the $10 for lunch. Today, we're lucky to have Bill Sandsgrant. It's going to be Go Faster, Sooner, Discover SQL Server Indexes, Prescriptions for the Biggest Performance Improvements. So I'm going to stop sharing and pass it over to you, Bill.
Okie doke, let me grab my screen. Let me know when you can see it.
I've got it. Thank you.
All right,
if you have any questions, please post them in the chat.
I'd be happy to address them as we go. Thanks for joining us. This is Go Faster Sooner, using indexes to make your server go faster and finding the places where you can make those improvements the quickest. By way of further introduction, there's the big PASS Community Summit coming up in November. Along with that, this year, PASS is introducing some new on tours in Dallas, New York, and Amsterdam in the third quarter of this year. It'd be interesting to see what those are like. I've also got a slide here on some of the resources that'll get you to the schedules for some of the SQL Saturdays, Data Saturdays, and then also with the Azure Data Tech Groups, which has a list of all of the community groups scattered around the world. By way of introduction, I'm Bill Sandsgrant. I've been working on SQL Server since the 6.5 days. Had the opportunity back in 1984 to write my first SQL statement using a metaphor computer system on a Britton Lee database machine. For those of you who have some advanced skills and knowledge, you maybe remember back that far, that was the bee's knees. Started a data consulting practice in 94, and around 2001 began the first version of what you're going to see today. Had the opportunity, thanks to COVID, to retire in 2020, and I have now been pursuing some passion projects. Again, this is one of the first ones. And on a personal note, I'm the record holder for the most SQL cruise as a student. Been on 10 SQL Server cruises and 2 for Oracle. And that's probably the best way to learn SQL, because you're, I don't want to say trapped on a cruise ship, but everybody's there. You meet up in the bars and you can trade war stories until the wee hours. It's a great way to learn. Hopefully, if you ever see Tim Ford, you can ask him to start the SQL Server SQL cruises back up again. And again, feel free to ask questions at any time. I'm going to be moving through the material pretty quick, and I want to make sure that everybody grasps what we're talking about. So to answer the question, why are we here? Microsoft says it best: indexes are primary sources of application bottlenecks. And what we're going to look at today is a way to determine where those are, where the biggest elements are, and how you can go about fixing those. I'm going to introduce a client story, one of my recent clients. who had a problem. They were in the business of membership and event management services. Think Taylor Swift and Ticketmaster, but not on that same scale. Their primary application has always been slow and getting slower, getting a lot of customer complaints. And the problem that they brought me in for is SQL Server failed when things got extremely busy on their busiest day ever. And they wanted to figure out what they could do to get out of that hole that they had dug for themselves. It ended up taking them 3 days to recover. They lost a lot of business. So they brought me in and I said, all right, let's figure out how we're going to get started on this. And among the many questions I ask in an engagement like this is, what are the things that we can do to make things work better? And I've led into a number of questions or statements that we can address relative to why index tuning may be a great place to start. Some of the signs include things like there's no money for hardware, or there's no staff available for refactoring and testing code. Even in the case where there's staff that can do refactoring, I've run into many cases where there isn't the testing staff available to test the changes. On the SQL Server side, Brent Ozar brings up the concept of poison weights. The two that I look for are what are called resource semaphore, meaning there's not enough memory to run the query that you're trying to execute, and thread pool, where there's not enough queues available for the work to be queued up to be executed. Similarly, there's scheduler yields. The activities that you've submitted to run are taking longer than the amount of time that SQL Server has said that they can stick on the CPU, and they have to go back on the scheduler queue and wait their turn so that they can multitask through whatever other queries are going on. Another one of our locking and latching weights. The more we see of these, more it indicates that the amount of work that we're trying to do has gotten bigger, and the amount of locking may be getting in the way of getting the work done. And of course, if you're running on Enterprise Edition, you can do your index maintenance online. And that's a huge advantage because you don't have to have any outage windows, and you can make these changes while your normal business day is going on. So how did I get here? Well, way back in the day, I'd take some community scripts, copy and paste them after running them, and try to figure out what they were trying to tell me, try to glue them together, come up with some actionable nuggets that I could execute. As time progressed, I figured out, going back almost 30 years ago, how to link SQL Server to Excel so I could pull the data into Excel and use its power to format and analyze the results and help stitch things together. I then took the best of the available community scripts and started combining them together. And here I want to take a moment to thank those who went before me and have contributed to my knowledge of indexing, and also contributed scripts and other things that I've used in the tool that you're going to see today. So continuing on with my skills, I extended it with all of the other resources that I could find that included more metadata, statistics, etc. And I also included some of the non-row store index details, some of the specialty indexes that go beyond just the simple row store indexes, and also added into it the history tables because they play a role in performance, sending the data into those or querying those, and then also the internal tables that are built behind the scenes for some of the specialty indexes like XML and spatial. So what did it look like after we're all done? Well, over 94 dynamic management views and functions are included, almost 1,000 columns, and over 200 performance and hurt metrics. So continuing on, put this all together by table and index, and then tried to turn it into a package, something I could return to the community. And I have, by way of name, called it SQL Excel Index, because I'm joining some of the best features of SQL and Excel. And in this case, we're going to be looking at how we can improve index tuning. So what makes this tool different? Well, the first thing I do is prioritize where we should start tuning by table. The table is the core element of how data is stored and organized. And if we can figure out where we've got our most hurtful accesses, we can figure out how to tune the system faster and concentrate our energies where the most pain is. Once we know where to start, need some idea on what we're going to do, so I prescribe some actions to take individually by index. Add a bunch of diagnostics so that you can understand how the prioritization and the prescriptions came up, and then also put together a comprehensive set of metadata and metrics so that all that information is available to you as you continue on your index tuning journey. Excuse me. So how do we go about prioritizing index tuning? Well, many of you have probably heard of the Pareto principle or the 80-20 rule. And basically it says 80% of your results are going to come from only 20% of your effort. Now you're probably asking yourself, how does this apply to indexes? Well, We know with all of the metrics that SQL Server collects on indexes, many of them can be classified as hurtful. For example, weights are telling us that SQL Server isn't able to gain access to the index when it wants to perform whatever activity it wants to perform. So if we can find all of those and then group them together and add them up by individual tables, we can identify the tables that we want to fix first. And what does this translate to into practice? Going back to our client story, we discovered that 82% of their hurt came from only 4% of their tables. And there's a whole lot of reasons for this, but we'll go into some of those as we continue through the presentation. So this was a real stunning thing for them to discover, that in spite of the efforts that they built over time, they had basically been causing problems with the application as they've been trying to improve it. So what are those hurts? I've grouped the nearly 100 hurt metrics into 12 different categories. I'm going to go through these quickly. Weights, obviously, this is SQL Server can't get to the resources it needs in order to use an index and do what it needs to do. Locking, the more locking, the more controlling of access, the less work is going to be able to get done. And this includes lock promotions and lock fails. Obviously, lock fails aren't something that we want to see too many of, because it means SQL Server just can't get access to the resources that it's looking for. Splits and merges, these are just adding overhead, either expanding or contracting the amount of space that's stored for the tables and indexes. And missing indexes, this is SQL Server trying to tell us, hey, I could do better if you would only help me build this index. Well, one of the things I want to do is to mention that there's a lot of fine print on the missing index limitations, and this comes directly from Microsoft. That's the link up above there. It only recommends non-clustered, row store, disk-based indexes. The challenge with that, of course, is it doesn't include any of the fancier indexes, some of the ones that have come out more recently. It also doesn't include filtered indexes or materialized views. So it kind of is a helpful tool for just one class of indexes. It only creates estimates from the first time, or the only time that a query gets optimized. And it'll count how many times that it sees that query pattern coming forward, but it's only going to use its estimates from that single query optimization. And without going into further detail, there's a whole lot of other things that you need to weigh when you decide you want to take a look at your missing indexes and decide what to do with them. Back to our list of metrics, we also include writes. The more writing we're doing may imply that we have too many indexes, or we're doing more maintenance than we need to on the application side. Continuing through the other categories, take a look at how much of these objects, the indexes and the underlying tables, are in memory. If more of the object is in memory, it may be a sign that we're doing more scanning than we need to. Also look at the ratio of how many times we're reading versus how many times we're writing to. I use as a simple metric, we should be reading at least 4 times as much as we're writing, because there's way more overhead involved with writing, between the locking, writing out to the log, storing it out on disk, etc. How often we're scanning. This excludes column stores, because column stores are only accessed through a scan. And then the alternative, which is a lookup, meaning that our index wasn't able to cover the query, and we had to go back to the source table in order to pull up some fields that weren't included in the index. Heaps, we're looking at how often we have to navigate our way through a heap that's had some manipulation done to it. And of course, large objects. These are being stored in a separate file group, and we have to have pointers back in the source records to where this data is, and there's maybe additional reads involved depending on how big some of these objects are. How do we go about weighing these hurts? Well, all the hurts aren't created equal, so a bunch of defaults are set up within the application to identify how much priority is given to each of these different hurts. So for example, weights, which is a clear indication that work can't get done, are going to get the highest priority. And then as you can see through the list, it trails off from there. Special note for in-memory objects, since those are built on a different engine pattern, there's and they tend to be way more efficient in terms of how quickly they can be executed against. We're going to use a deflating factor for those in order to not overweight them, because we typically put these things in memory in order to speed up your performance, and they're going to get hit a lot. So how do we go about prioritizing the hurt? We've got our metrics, we've got them weighted. So for each of these metrics, if we add them up at the table level, total all of the hurts across all the tables, and then we can figure out what percent each table is of the grand total. Apply that hurt weighting factor, total up the metrics by table, and then we can present the results in descending order of hurt. Now we're going to get into what this looks like in practice. I'm going to switch over to my Excel sheet. And if you've downloaded this from the SQL Excel GitHub site, you'll open up to this page. There's some information on how to execute all these things, along with how to make sure that you get access to the sheet because it's got some macros in it, and Microsoft wants to let you know that they're there. There's also a copy of 28,000 lines of SQL code that you're going to want to copy and paste into Management Studio and execute. It's going to build a series of objects, temporary objects, a handful of persisted functions because you can't create temporary functions. And once you've executed that, you're going to switch over to the Index tab. Switching over to the Index tab, and you can click on this Get SQL Data button, and it'll automatically pull the data from your SQL Server into the spreadsheet. If you're working on a jump box and you don't have Excel installed on that jump box, you can export the same data to a text file, bring the text file over to your workstation or wherever you have Excel installed, and then import it into Excel, and you'll get the same results as if you had connected directly to the SQL Server. So there's a lot of information that's been brought back here, almost 300 columns. But in order to simplify navigating your way through it, there's a drop down here that includes a number of different drop down is not working, which is kind of strange. It's always nice when a demo goes wild like this. I'm zoomed in. I'm going to try to zoom out and see if that helps with the display. It might also be a Teams artifact. It doesn't look like it's getting any better. All right, well, embarrassingly, this is supposed to be a drop-down that has about 20 different categorizations of how this data is organized. This first screen that we're looking at are hertz at the table level. I'm going to zoom back in so that you can see it a little bit better. And what we see across the top here are a whole bunch of different weight categories. These are all of the different weights that we talked about. Some of them are broken out. So for example, with the weights, I have both the time and the count so that you can review those separately if you'd like. But as you can see, each of these is color-coded so you can identify across the tables which ones are causing you the biggest hurt along that metric, and also the ones that are causing you the least hurt. Going across the top here, there's a couple additional buttons. Once you've drilled into some of the underlying data, you can remove the filter that's been established on there, and I'll show how that works. And then also there's a button to control how these columns are grouped together so that you can create your own column groupings to help you with your index quest. So we've got a whole bunch of these metrics here of hurt. As far as some of the original metadata that we're showing, let me zoom and show those in more detail. Give you an idea of the database, the schema, and the table name that these objects are attached to. And we'll also include in here views and SQL table valued functions. You can order the results coming out of a SQL table valued function, and it looks to the system kind of like an index. So it has some idea of how the results are going to get presented to it. So all of those are included in here. And then we also include some of the hidden numbers that SQL Server uses to keep track of these objects uniquely. So this is database 5, and this is table with a big number. Next column over, column D, is a grouping category so that you can identify related objects. For example, I want to see all of the in-memory tables, or all of the tables that have system versioning, or all of the full text indexes. The money column is column B. This is the one where all of the hurt metrics have been added up and accumulated to a single total, and then the results are displayed by the table with the worst hurt first. And I'm going to reasonably quickly demonstrate, that when you add up just these first 4 indexes, they are, zooming in, there we go. Nope, that didn't work. Let's try this again. Yep, it's not doing what I want. Let me try to hide my taskbar again. Oh, One of the nice features of Teams is it's quite the resource. So unfortunately, I'm not going to be able to demonstrate that, but these four together, as you can see, are almost 50% of the hertz on this particular sample that was done. This is on the Wide World Importers database, one of the Microsoft sample databases, after having executed a number of the workload patterns that are included with that database. So these results are not representative of any real work. Instead, this is a artificial workload, but it's useful because it gives a good demonstration of how the basic concepts behind this works. Switching back to the presentation, going to go back to our client story. After we find out that there's only 21 tables, or the 4%, that they make sense because they recognize that because of the amount of work that they've done trying to make performance better, these are the same names that keep popping up over and over again. So it makes sense to them, but what do we do to make the hurt go away? Go ahead.
Bill?
Yeah.
Do you need to set the query store on for these statistics and these numbers?
No, these are the base operational and usage metrics that are captured by SQL Server since all the way back in the 2000, 2005 days. So I'm not using any of the query store. I'm not using any extended events. These are just the simple dynamic management views and functions that capture at the server level and the database level, both the metadata and the operational and performance metrics.
And then Paresh had asked a question about, since these days all the disks are flash, how useful are the IMOLTP objects?
What do you mean by IMO? The in-memory objects?
Yeah.
Okay, yeah. It still depends. Even with high performance PCIe 4 and 5 NVMe disks, you're still looking at a 100-fold or more performance difference between in-memory and NVMe. In fact, it's probably even higher than that. So if you've got a lot of stuff where you're rapidly looking up data, having it in memory and accessible readily is always a good thing. Or if you're looking at rapid inventory changes, those are the two use cases that I've seen the most often, where you want to keep track of those objects as close as you can to real time. But yeah, obviously you need to have a lot of memory for those. And more and more clients have gone away from it because by the time all of the management and maintenance of those in-memory objects goes on, they end up chewing up way more memory than the clients thought they were going to be. And with a lot of them running in the cloud, upsizing has become a little too expensive relative to the amount of performance they gained having these in-memory objects. Great question. All right, so how do we make the hurt go away? Well, I've grouped the prescriptions into 8 different categories, and I'm going to go through these real quick. First off is retain. These are the indexes that somebody took the time to architect and design. The clustered indexes, constraints, some of our specialty indexes, history tables, and of course the internal tables that come with the XML, full text, and spatial indexes. Or those indexes that are required by others. For example, you have to have a unique index supporting a full text index once you've created that full text index. Replacement, these are the things that can be replaced by non-clustered column stores, the updatable non-clustered column store that came in SQL 2016 plus SQL 2016 and above enterprise. If you have that, you can get all of the benefits of clustered indexes with the ability to keep them updated with the underlying changes to your row store objects. So this is a really great alternative for reporting and analytics that people may have built specialty indexes for or regular row store indexes for just to speed up those reports. And as I said, it can replace some of the non-clustered row store indexes that people have already built or even be used to address missing index requests. And we'll get into more of that in a moment. So some of the things that we are going to include are those indexes that aren't getting a lot of usage or have a low read to write ratio, and also are the low value missing indexes where SQL Server says, hey, this might help, but it's not going to get enough usage to justify it being built. Requests, these are new indexes that are going to be built on, say, active heaps, or missing indexes that we've identified are going to be valuable, or covers on foreign keys, typically where we've also got a missing index recommendation that covers that foreign key. And of course, we're going to recommend where it makes sense to build or request new updatable non-cluster column stores on tables that don't already have it. We're going to reject some of those missing index recommendations that don't add significant value, or in turn are going to be covered by an existing or a future non-cluster column store. And we'll talk a little bit more about some of the rules behind that in a moment. We're going to remove those indexes that are costing more than they benefit. Again, the 4 reads per write is the ratio. Or if we've got the case of duplicate indexes, we're going to get rid of the one that's the least used, or where we've got a redundant foreign key constraint. Obviously, we don't need to have redundant foreign keys, but I'm surprised at how often I've run into this. Review. It wouldn't be SQL Server if we didn't have a category for it depends, but where we've identified one of the 5 categories above, this is where we may want to take a look at some of the additional index properties. For example, this might be a category of filtered index, where we've got, using the statistics, a wide range of rows per lead key element on the index. Or we've got a non-persisted computed column in the index, or the index has got a potentially temporary naming basis. Somebody's put a date in there, or somebody's put in a trial, or it's even created by the data tuning advisor, and we don't think we need it anymore. Or we've got high page compression failures, or the index is disabled and not trusted. Run into this quite a bit. Somebody built an index and disabled it and never came around to getting rid of it. Or again, where we've got synergies and overlaps. We may want to take a look at where we have a case where an index is fully covered by another index, but the keys aren't in the same sequence or the same order. Refreshing, this is where we've seen from the statistics that there's been a lot of row modifications, updates, deletes, or where there's been a lot of inserts and deletes where the row count captured by the statistics no longer matches the physical table row count. And then with column stores, because of the way they're built, the actual mechanism of inserting and updating records is handled by some delta stores, which are independent objects that aren't part of the physical column store until an activity runs to process and build them into the column store. So we're going to flag those as where we need to take these delta stores and reprocess them, or in the case that our processing has built multiple undersized column store row groups, meaning we haven't built them out to their fullest size, we may want to go about rebuilding those in order to squeeze them into fewer objects. And refactoring, this is where a lot of heavy lifting is going to come in. This is where we've got indexes where we've got row store indexes where adding keys to the index isn't making the index more selective. The index is working harder to be maintained, but it's not returning fewer rows as we add more keys to the index. Similarly, where we've got a high fill factor, but we've also got high page splits, or the opposite, where we've got a low fill factor and no splits. Or we've got a partition not matching issue, where the index partition doesn't match the table partition, or a collation mismatch, or page and row locking is not enabled, especially seeing this on databases that have converted up from 2005 and 2008. Or it's a clustered row store index that doesn't have the acronym news to it, which is narrow, unique, static, and ever increasing, which is a design pattern that I like to see indexes have. So what does this look like in reality? I'm going to switch back to the spreadsheet, and this is where things are going to get a little bit dicey. I'm going to try to address with my drop down here, which is not working because that's what I use in order to toggle to other parts of the sheet. Well, I'm going to start with an option that's built into the sheet, which is taking the lead table that has the most degree of hertz. I'm going to click on the cell B27 attached to this row, and it's going to drill down to the index level itself. And this is going to show me prescription and diagnostic information. I'm going to change this if it allows me to. Let me see if I zoom out to the 100% level, if it'll work for me here. There we go. Yes. I'm going to switch this to take a look at index hert and prescriptions. And then I'll zoom back in. Oh, I love the way this is working with the zoom function. So I'm going to zoom back in, zooming, one more zoom. Now what we see here are the list of the same hertz across the rows, but are across the columns, but these are now at the index level. And like the previous one, which I don't think I mentioned, These are their percent of the total for the table. At the table level, that's that table's percent of the total for the sample. And you can sample either a single database, all user databases, or all databases on the server, including the system and whatever other tables might be on there. So with these same metrics, you can now look individually by index where the herd is coming from within this table. Some additional information has been added over here. We include the name of the index and some narrative or abbreviation for what kind it is. The CX stands for clustering, and this is the name of the index, PK sales order lines. And we also recognize that this is the primary key on the table. And we've added another behind the scenes ID, the index ID in this table, so that we can go find it if we want to go look it up in some of the other dynamic management views. From a prescription perspective, this is how it's going to be presented. We're going to retain this index because it's the clustering index, going back to the rule around those things were architected or designed. Somebody took the time to say this is going to be the clustering index, so we're going to keep that. Then we're going to add some elements for the refactoring. There's a new element that came in SQL Server 2019 called Optimize for Sequential Key. The lead key on this table, the clustering key on this table, is a sequence. And this new feature allows, especially where there's a lot of bulk inserting going on, to optimize those inserts into a table organized by a sequential key. So it wasn't turned on, flagging this as a possibility to turn on. And because this is a dummy workload that came from a fresh database and then applied several years of virtual work to it, there's been a whole lot of records inserted and updated. And by taking a look at the changes that have been identified or the modifications identified within the statistics, this may be an object that we want to turn off the automatic statistics recomputation. Obviously, depending on the workload and depending on what you're doing with this table, this may or may not be a feature that you want to keep or not, and also depending on the schedule of how often you're reorganizing or rebuilding your indexes. But you may want to turn this feature off so that you're not taking a hit in the middle of the business day when SQL Server says, hey, I got to recompute statistics on this index. Similarly, saying, hey, we may want to refresh this the statistics on this index because there's a difference between the rows that were captured when the statistics were last run and the number of rows in the physical table when we took our sample running the SQL XL index tool. So that gives you kind of a quick idea of what some of those look like. I'm going to scroll down and we're going to take a look at a couple more. For the next index, this is a non-clustered column store. And we're going to retain it because somebody made the effort to build this as part of an architectural decision. Or after having run my tool, they've decided, hey, this is something that we actually want to have. But we're also flagging the fact that we're going to want to refactor it and add some index columns, some key columns from indexes. Some of the indexes qualify for being replaced by the non-clustered column store. And you can get only one non-clustered column store for a table. So any key that you want to use within that column store has to be added to the column store itself before you replace the index. Otherwise, you're not going to be able to take advantage of that non-clustered column store. And I'll show you when we get to the diagnostics and the metadata, how those are flagged for you so you know which ones to build. Next one down is the standard non-clustered row store index. We're going to keep this one, but it's one, and we'll show how this works. This is the best of the several indexes that have the same key sequence. And by best, I mean this is the one that is getting the most usage. And based on how many records are getting returned based on the keys involved, there's no need to keep those other indexes around because this one is already covering most of the requests along this same key sequence pattern. We're going to want to take a look at those synergy indexes, as I call them, where we've got keys in the same sequence. And again, we're going to flag this as an index that we want to update the statistics on because there's been a lot of activity on it. And we want to make sure the statistics are as good as possible for the query optimizer. This last one we're going to take a look at, it's another non-clustered row store. When we get into the diagnostics, we'll see why we're recommending it gets replaced by the existing non-clustered column store. but it's probably because it's not getting a lot of use. Alternatively, if we want to keep it, because of the way the statistics histogram buckets are built, there's a significant difference between the most number of rows and the least number of rows across the histogram buckets. So this might be an opportunity for filtering, either based on the physical number of buckets that were computed, meaning there's not too many of them, like in the case of an open or closed order status, or we're looking at a lookup field where there's only a handful of different choices on order fulfillment status, for example. So with all that said, let's go back to the presentation and we'll continue on. So what happened after we ran this for the client? Yeah, go ahead.
One more question. So they were asking about its support for Azure, and Tony responded that yes, it was listed in your GitHub. But the second question that he was asking is,
I don't want to qualify that. It's Azure SQL DB and managed instances. And I've had a handful of people run it in both, and it seems to work okay. I know a lot of other tools like Blitz Index don't work in that, and I can, after having figured out how to get it to work, and I can understand why they don't. Okay, so go ahead.
The other one is, do you run this individually on each database, or can you run it across all the databases on one server at one time?
Typically, I've run it across all user databases at one time. That, of course, extends the runtime, but you're looking for making the server go faster. So if you've got a case where you've got multiple databases or multiple applications sharing a server, you're going to want to look for the biggest pain across all those tables, across all those databases, across all those applications. So I typically start with and typically finish with running it across all of the databases because you're looking at the server level. How do you make the server go faster?
Sounds great. That's all I have.
Okay. All right. So from the client perspective, what did this do? Well, in order to make it happen, we disabled index maintenance jobs because if you're doing rebuilds, it can reset the operational metrics. And those are the ones that capture how often the individual indexes were used versus the usage metrics, which are how often it appeared in a query, in a optimization query strategy. So once we turned those off, they went through their weekly server maintenance. They always restarted their server every week. We ran the business for a week and then built a baseline from that first week's metrics. Armed with the baseline, we applied the prescriptions to the 21 tables, restarted the server again, captured the statistics after that next week, and then we compared the after to the before. And this is definitely not a science. It's more of an art because what they thought was that the workload was mostly similar, but they couldn't guarantee it. And in turn, the different ratios, the different counts and amounts were off a little bit slightly, but we were able to come up with some generic categorizations that I'll share with you. So what happened? Well, taking a look at the week over week improvements, resource semaphore, thread pool, and other weights went down as a share of the total weights on the server. And these were obviously very dramatic improvements because it basically says, hey, there's more memory available to handle the queries that they're running, or the query strategies are more efficient in the amount of memory that they're looking for. And similarly, fewer queries were going parallel, meaning that there weren't as many tasks that were being tried to be executed at the same time. And the same thing with the scheduler yield and the locking and latching. From the index HERP perspective, wait times dropped in the aggregate 77%. In terms of the total number of waits, times and counts, went down 77%. And all of the other key ones went down. Not all of them went down. As we noticed, buffer cache usage didn't change. Well, that's just because now different data is being captured in the buffer cache because SQL Server wants to keep as much as it can in the buffer cache so it doesn't have to go to disk to read the information that it has already read in. But it's not all rainbows and unicorns when it comes to working with this information. As we talked a little bit before, the performance metrics, missing indexes, and statistics can get reset on an instance restart, taking the database offline or online. I've had a couple cases where clients had auto close on, which of course wiped out the statistics. We had to turn that off before we could get reasonable statistics. Detaching and attaching a database or memory pressure might clear some of the metadata. For example, the operational statistics can get merged out if you've got some serious memory pressure. If you're doing index rebuilds, as I said, it's going to reset the operational metrics. And on earlier versions of SQL Server 2012 and 2014, you have to watch out for it because the usage metrics can be reset on rebuilds. Or if you're doing metadata changes, creating, changing, and dropping indexes, disabling and enabling indexes, or if you've got auto update statistics turned on, it's going to change your statistics. So you're not going to get the same insights into how frequently or less frequently you should be updating your statistics. So why are we going to about doing this? It's over 500 diagnostics built into the tool. First category are the things that are good to know, like when was the last time this got looked at? Or what are some of the key configuration properties at the server, instance, database, query store, and other levels? So you can get a rough idea of what you're up against, not just at the index and table level, but at the database and instance level. Also flag things that stand out, like where somebody has changed some of the properties. Max degree of parallelism has changed, or somebody has changed cost threshold for parallelism. Or at the database level, there's been some database level configuration changes made. Or where we've got the high proportion of a particular herd or metric, the weights, locks, splits, and merges. Or anti-patterns like some big included columns. The more included columns you have in your indexes, the bigger your indexes become, and the bigger and the more amount of work you have to do in order to maintain all those indexes. And then if we've got some included uncovered foreign keys that have a missing index recommendation. And these are specific to the keys and the foreign keys. If you have missing indexes that have more columns than what's in the foreign key, to me, that means that the foreign key wasn't being accessed. It was just some other query was looking beyond the elements in the foreign key. And then as a guide, I also linked to the 58 checks that are built into Brent Ozar's Blitz Index tool. That's a handy reference for some of these things and why it's important, not important, or the resources that you can use to follow up on it. So switching to another demo, let's go back in and take a look at some of what these detailed diagnostics look like. And I apologize in advance if this button click doesn't work. Oh, it's appearing now on my other screen. So that's interesting. So I'm going to toggle to the index prescriptions and diagnostics. And using that same table that we highlighted, the order lines table, I'm going to look at what some of these diagnostics are. Now, one of the nice things about Excel is you can do a lot of work with Visual Basic for applications behind the scenes or building macros behind the scenes. And one of the things that you can do is if you click on a cell, I can control its size. So even though it looked like there's not a whole lot of information in there, I can expand both height and width, the size of the cell, to show more information. And that's a very powerful way to include more information in the spreadsheet, take advantage of the fact that you can put lots of information in a single cell, but then when you move off of that, you can get back to the regular display and get kind of a broader view of what's going on. But looking across what some of these diagnostics are, at the aggregate level, indexes are almost 3 times the size of the parent table. At some point, obviously, having more space in the indexes than you have in the physical table is kind of defeating the purpose of having the indexes. There needs to be a balance between finding what you're looking for and going back to the base table in order to pull it out, and indexes that provide cover for specific queries that are being executed frequently. This particular index has 13 non-clustered indexes, of which 11 are categorized as low read, meaning they're less than 2% of all the reads on the table. And the recommendation here is to consider using the existing non-clustered column store. From an operations perspective, meaning how often this index actually got used, how often it got interrogated as part of a query execution, it's got a low read to write ratio. At the aggregate level, there are 30.1 million reads, but only 9.27 million writes for a read-write ratio of 3.25. And this ties to Brent Ozar's Blitz Index grouping 48. Similarly, for the usage, how often it appeared in queries, not how often it got actually physically interrogated. Same thing, 7.5 million reads to almost 8 million writes, to a ratio of just about 1 read per write. It has a default column that's included on the last edited when, and we'll see from the metadata what that looks like. It's got 1 non-index filtered statistics built on it. And it has as its element a sequence column that's at the order line ID column. It's 0.02% used, 511,000 out of 2.5 or 2.15 billion numbers have been assigned. Don't know when it was last used because the different indexes all have different usage dates. And it's got a high ratio of page to row locks, meaning we're probably doing more scanning than seeking across all of these indexes. And overall, 99% of this index and this table and all of its indexes are in memory, meaning it's being accessed frequently enough that SQL Server has still got it in memory at the time this ran. Obviously, your workload is going to ebb and flow, and you're going to see things come and go from the buffer. So this is just a snapshot in one moment in time. Run this over a couple different days, over a couple different time periods, a couple different workloads. Will give you a better idea of how the application is ebbing and flowing in its usage of memory. And then I'm not going to go into all of these, but these are some of the hurt metrics and their computations behind the scenes on how much these things are hurting. So for the waits, total wait time based on the sample workload was 1.17 seconds, which was 16.6% of the total for the server, which makes it the number 3 most waited for object in the server. So all of the indexes, clustering index on this table was the 3rd most waited on object. It only got waited on, though, 540 times, which is less than 1% of the total. The overall average was 2.17 milliseconds for those 540 waits. Again, this ties to the Blitz index number 11 grouping. Continuing on, I'm going to scroll down. Scrolling down and go back up to the clustering index. And similarly, we have some narrative about what this is as you're looking at it. Tried to put as much useful information into a single cell as possible so that you don't have to scroll back and forth even within the sheet in order to find the information you're looking for. This particular index has low read to write ratio. It's at 100% fill factor, and there were almost 6,000 splits, but it was only 1% of all of the inserts and updates that were performed against this index. So not too bad. Again, inside the clustering index, there's a defaulted column, the order line ID. We already saw that that's a sequence. It was last read a day ago because I just updated the database today. High ratio of page to row locks. So we're doing quite a bit of scanning in order to accommodate more page locks versus row locks. Statistics were recently completed on 30% of the rows, and the sample was set to be persisted at 30% when they're being updated. To capture how many histogram steps there were 53. And the ratio between the bucket, histogram bucket with the most number of rows to the least number of rows is a factor of 1.14. But because this is a sequence, it's not as important, and also references the fact that histogram, the elements that make up the histogram, the key elements of the index are not nullable. It also flags the fact from the statistics that have been captured since the database was restored, or the statistics were last run. There are 54.7% more rows than there were when the statistics were captured. There's now 511,000 rows, previously 231,000, or a difference of 54.7%. Of the original 231,000 rows, they've been modified 121%, meaning as far as the statistics knows, it looks like all of the rows have been touched with an update. And then similarly, compute that metric, or show you that metric here, and mentioning again here, enabling the no recompute. We flag the fact that there's synergy between this index at the sequence level, meaning that the keys are in the same order, and we'll take a look at that. Reference again that the lead key is a sequence and the optimize for sequential key is not enabled. It's a unique index, but overall the statistics are showing 1.01 records per key across the single key element in this case. So the statistics, because they were based on a sample, aren't as accurate as they could be if the entire table was sampled. And this particular index is 100% in the buffer cache, meaning the entirety of the contents or the entirety of the table, because that's a clustering index, are in memory at this time. And similarly, the metrics for this index within the table are computed here. So this only was weighted on 23 milliseconds, 6 times, average wait of 3.83 milliseconds. And again, we have some of the other metrics here too. I use a set of abbreviations that so far have been pretty straightforward to figure out. There's a tab down here called abbreviations that goes into more detail about what each of these things mean. But if there's questions, of course, you can reach out to me and I'll try to explain what they mean, and I'll add that to the next release so that it's easier for people to understand what information I'm trying to show here. So let's go back to the presentation. Now that we've seen the diagnostics, what about all the metadata? Well, there's hundreds of columns in here. It includes pretty much everything I have found has been useful in my index tuning journeys. And let's take a look at what that looks like. Go back to the sheet. And
hey, Bill, you have about 10 minutes left.
Yeah, hopefully we will get through this. And you can see now that the display, for whatever reason, is showing up across both screens. But I'm going to switch to index metadata. And we're going to get into some more columns that are now presented for detailed metadata about each of the indexes, the table level, also at the database and server level. So I'm going to click over here on the first column I want to display, column I. This is a list of all of the columns in the table, along with some representations of how they're stored. So the order line ID is a 4-byte integer. It's a default with a sequence of increment 1. And for each row, or for each value in the key, there's 1.36 rows on average returned. Again, this goes back to the statistics not being very accurate, given that there should never be more than one row, since this is a sequential key. There's 154 steps in the histogram for this table, and the sniffing, again, I'll tie to the clustering index, is a 1.14 to the histogram bucket with the most records to the histogram bucket with the least records. And then that continues through all of the columns in the table. And then the column immediately adjacent, based on a request from some community members, this breaks down, similar to what's in Blitz Index, all of the uses of all of these columns across all of the indexes, foreign keys, non-cluster column stores, and missing indexes. So this first key, the order line ID, appears as the clustering index lead. It appears as the lead element in 3 row stores and as an additional key in 4 other indexes. Similarly, the order ID is the lead element in 3 row stores, a key in 4. It's included in 1 row store. It's also the lead element in 2 foreign keys, and also appears in the non-clustered column store. So this gives you a quick snapshot overall of the index coverage across the columns in your table. Going down to the first index, the clustering index, we have our order line ID as a single element. And now we're going to introduce some details from the index for this, the statistics for this index. Based on the records that were in the clustered index at the time this ran, on average, there's 1.01 records per key using the order line ID. As we scroll down, I'm going to take a look at another one here. Scrolling down. So for this index, it's another non-clustered row store. There's 2 elements in the key. I'm going to expand that. The stock item ID and the picking completed when. Behind the scenes, of course, statistics are captured on the index, and using the first key alone, 2.25 thousand records get returned for each unique stock item ID. And that's 0.44% of all the records in the table. If you include the 2 key elements, we get down to 1.72 records for the 2 keys, or less than 1/100th of the records in the table. But I also mention here, or include the fact that since this isn't a unique index, in order to tie this back to the underlying physical table or any non-clustered index, we need to be able to tie back to the physical data in the table. So the clustering element and the cluster key elements are included in this as an additional hidden column in the index. And I flagged that because that's also included in the statistics, and it shows, in this case, 0.96 records for all 3 keys being included if you were to mention them either in a where clause or in a join condition. I'm going to scroll back up to our clustering index, and jumping across now to the synergies column. This is where the concept of overlapping or synergistic energies is introduced. We have a bunch of different indexes that have similar keys, and if you were to sort or filter on these core elements, meaning there's a sequence redundancy across the first column in the table, you could identify the other indexes that have that same key element as its lead element. You could also sort each of these columns by clicking on the column head. And that gives you another way to identify where you've got similar columns appearing row after row. A couple other highlights. There's some simple metrics about how big the table is and the row size, what's being stored out on disk, the buffer size, how many rows there are, how big the key is and what its length is, how many included columns are there and how long they are, and what the current fill factor is and whether the tree padding is turned on. Similarly, number of reads, writes, the ratio, how many wait seconds and wait count, and how many locks have occurred across this. Scrolling across, there's a couple other pieces. We show the default column here, which is a sequence, and it's using the next value. And there's it's also the primary key, and the name of the primary key is the sales order line. Include information about, scrolling over, the table file and partitions, and if there's any extended properties that have been built, what those extended properties are. One other thing, if you're running 2019 or above, scrolling over. So I don't like doing this on Teams. Come on. Okay, one more time. All right, well, this also goes out and looks at the missing query elements and identifies the query that was last captured in SQL 2019 or above on missing indexes for what is the query that has the greatest usage, weighted usage, and what that query looks like. So you have that as another indicator to whether or not this is a missing index that you want to include. All right, going through the remainder of the presentation. How do I typically go about executing this code, running it again for all of the databases on the server, because you're looking at tuning the server. In the case of this particular client, it took 38 seconds. It has several parameters. You can run it either for a single database, all the user databases, or all of the databases. So if you want to get your data warehousing elements, you want to get the usage of TempDB, et cetera, you can capture those too. Options on how you want to cover foreign keys. Do I want to cover? Do I always want to cover? Do I want to keep the ones that are there? Do I want to create or not create non-cluster column stores? Some places don't want to create those. And then you can also change the HERT weightings for each of the HERT metrics. It works on the box product 2012 and above, Azure SQL Database, a managed instance, and it requires a connection either directly to Excel from the Excel spreadsheet, or if you use a jump box, you can export the data to a text file and then import it into Excel. How do I typically go about applying fixes? Well, I create 2 clones, one for the current state and one to make changes to using like a DDL comparison tool, for example. I apply the changes to the clone database and I create Delta scripts using a DDL comparison tool. I have given up trying to create scripts to do that directly. Plan for lots and lots of log file, of course. And I always like to batch changes by table. So I'll build individual scripts tied to an individual's table changes, because inevitably there's going to need to be some rollbacks, something you didn't consider, something that the DDL comparison tool wasn't able to incorporate. And in the event that you have to roll back, it's going to be easier to do it at a single table level. Also consider disable before dropping indexes. That way the metadata is still there, so it's going to be easier to rebuild. And if you have a secondary, check to make sure that that index isn't being used on that secondary for reporting or analytics. Once I've got my Delta scripts, I apply them to the target database. After we're all done, I recompare what I ended up with, what I wanted the target to look like, and I look at any discrepancies. And of course, if the stuff hits the fan, I'm going to create a rollback from the clone copy that I made, so I have the previous state also available to me in the event I have to do further rollbacks. So how did this affect the client? Well, they lived happily ever after. They had another even bigger membership event. The CPU maxed out at 32%. No issues were reported. And even more importantly to them and their clients, there were no performance complaints. So they kind of started rebuilding trust after the server dropping out on them. So how do we do that? Well, we completed most of the remaining prescriptions, including lots of non-cluster column stores. We removed a bunch of indexes, and we built a bunch of high-valued missing indexes, put a lot of clusters on heaps, even though they were small. Some of them were being used as queuing tables, and they didn't realize how much those were hurting them not having indexes on them. And also covered a bunch of foreign keys. They were doing a lot more key maintenance behind the scenes than they thought they were. So on that note, let's open it up to any further questions that we have. My contact information is here, along with references to some of the principal sources that I used when I started building this. Brent Ozar's Splits Index tool. Glenn Berry's got his diagnostic information queries. Aaron Bertrand put out 40 table property queries. And the book, if you're interested in learning more about indexes, that I recommend is the Expert Performing Indexing book that was recently updated for 2022. And they've made commitments to update it for 2025. Also, if you want to take a look at those, the index checks that are built into the Blitz Index tool, I've got a link for that down below. Look forward to hearing from you, learning from your experiences in using the tool, and continuing to make this a powerful, capable, comprehensive, useful tool for the SQL Server community. Thanks again for attending, and reach out to me if you have any further questions, or again, reach out to the moderators if you have any questions now. Thanks.
So Bill, one person was just asking, do you have to enable macros in the Excel?
Yes, you will. It will prompt you that you have macros, and you're going to need to enable those. I cannot say that there are no bugs in them, but there is no malicious code that I certainly put in there. Well,
okay.
You have to believe me because I unfortunately, unless you look at the code yourself, you'll just have to believe that I tried to do my homework on that. Sorry.
So I told them that you were using the worldwide importers, and at the end you were kind of talking about the database and what's going on. But so did you have queries or a process where you were doing inserts and updates and changing the data so that you could do the the before and then a week later, that kind of a comparison? Or
with the production database with the client, this was their actual database, their actual server. It actually had a couple different databases on it. And I ran the tool once we got a clean restart and turned off all of their index and statistics maintenance jobs. They were updating their indexes, rebuilding their indexes using the Ola Hollengren tool along with the statistics every night. We turned all that off so that we had a clean slate. So we actually captured a complete week's worth of results in week one. And then we captured all of the metadata, the metrics, statistics that we could. And then we use those to compare against the next week after we'd made the changes to the underlying indexes. So the method was, go ahead.
In your sample that you were doing with the worldwide, did you also have scripts that ran and updated data?
Yeah, Microsoft includes with the database, the sample database, a number of scripts that you can execute to simulate actual orders being processed and fulfilled and metrics being captured for temperatures on vehicles and warehouses and stuff. So it simulates an actual production workload. So based on restoring the database, executing that workload, I could build the metrics that are in the sample to show that there had been substantial activity since the restoration of the database. So that's provided by Microsoft, and there's a handful of different ones, including ones for building out a data warehouse component using that same data.
Okay, that's great. And I think there was only one other question. I think it's on the previous Excel spreadsheet. They said after entering the SQL Server name on row 14 and clicked Get SQL Data cell, just selects, but no action was performed. is that correct? Is there anything that they missed on that?
Coming back here, if they're still online, I hope. If they've added, I'm going to try to zoom in here, the address of the server that they're trying to connect to. Everything else defaults to tempdb if that's where they built their stuff. And similarly, if they're using Windows authentication, they don't need to enter their username and password. Once they've entered those 4 things, if those are necessary, then when they come into the index tab, it will connect to the database that they've selected or tempdb if they didn't. And if they click on that button, at the most that what should do is go out, capture the data, pull it into the spreadsheet. If there's a problem, it should pop up with an error message indicating why it wasn't able to either connect to the server, there was a rights or login issue, or some other problem with perhaps a missing object, because the database that they built, the temporary objects that capture all of the data for this application are all in tempdb. And some of the special functions, though, because they have to be persisted, because you can't create temporary functions, may be in a different database than the one they're trying to connect to with the Excel spreadsheet. So if they want to reach out to me, I'd be happy to work through this with them and get this to work in their environment.
Jason mentioned that he's been testing and it looks that the solution works fine with the SQL 2025 CTP.
Nice. Yeah, I have been concentrating on fixing and improving things based on community feedback. So I haven't started playing around with 2025 yet. So thanks, Jason.
And that seems to be all the questions. Wonderful presentation, very useful tool, and looking forward to going to the GitHub and getting the download. Thank you again.
Yeah, the code is out there separately from the spreadsheet if you want to take a look at it. There's a couple thousand lines of Visual Basic code that are built into the sheet if you want to take a look at that and make sure that there's, I'm not doing anything malicious behind the scenes. Feel free to reach out with any improvement suggestions, comments, criticisms, things you want to see changed. One common feedback before I added the abbreviations tab is, what do these abbreviations mean? They make sense to me, but they didn't make sense to everybody. So I've tried to put the abbreviation sheet out there, and I've also tried to spell out more of the elements where I've had the most questions about them. So feel free to reach out early and often. I'll be standing by. Like I said, I'm retired, and this is my passion project. So I'm eager to make it as successful in the community as I can.
Thank you very much. Really wonderful. Yeah, wonderful presentation.
Thanks for the opportunity, awesome. And reach out to me if you want me to join or speak at some of your user groups.